All right, so the first one, find the z-scores for 200 and 220. So the first z-score is going to be 200 minus 225 over my standard deviation of 10. So you guys got negative, it's below the mean, so it better be negative, negative 2.5. And the other z-score was 220 minus, minus 225 over 10, so that's negative 0.5. All right, so these are my z-scores here. The next thing we're asking is to find the probability that x is between 200 and 220. So everybody look up for a second. The probability x is between 200 and 220 is the same thing as the probability that z is between the z-score for 200 and the z-score for 220. Do you guys see what I'm saying? The x's, the calories being between 200 and 220, is the same thing as their z-scores being between whatever their z-scores is. The z-score for 200 is negative 2.5. The z-score for 220 is negative 0.5. So the calories being between 200 and 220, the same thing as the z-scores being between negative 2.5 and negative 0.5. Those mean the same thing. So we need to draw a picture. Draw a little picture. Here's my little notch. Negative 2.5 is over here somewhere. And negative 0.5 is over here somewhere. Doesn't have to be to scale, that's okay. And then you're going to shade, it says x is between those, or z is between these, so I'm just going to shade between them. All right. How to find the area between two z-scores? Anybody? Yep. Normal CDF. Of the lower z-score, negative 2.5, comma the upper z-score, negative 0.5, and you guys got what?
0.3023.
3023. That means that this area inside of here is 0.3023. That's the area inside of this here. So what does that mean in words? Someone tell me, using the words calories and chocolate bars, what this means. What does this represent? What does it mean? The values of the what? Of the calories. Okay, so 30.23% of the population, what's the population? Population is all cats, all puppy dogs, all chocolate bars. 30.23% of all chocolate bars will have what? Calories between
200 and 220.
200 and 225. Right, together you guys can kind of work this out, right? Does that sort of make sense? So, so between 200 and 220 calories, 30.23% of the population lies between those two, of all these chocolate bars. Yes?
So when it says like find the z-scores for blank and blank, it means like between?
Yes. Find the z-scores for, what are you talking about?
So it says, like for example, interlactose is between, and so
Yeah.
these kind of things.
Yes. So you need to find the z-score for each of them. So it says find the z-scores for 200 and 220 means, so you guys listen up. Find the z-scores between 200 and 220 means find the z-score for 200. How far is 200 away from the mean? How many standard deviations is that? Find the z-score for 220. Right? How far is it from the mean? How many standard deviations is it away from the mean? Good?
So what does it mean when it says between?
Between the two, you have to find the z-scores for each of them. You have to convert each. Those are the two values you care about. You need to find the z-score for each of those values. Right? Because I don't know I don't know what those numbers are if I left them as x values, because then I'd have to make a whole new distribution and try to calculate what it is for all of those values in between. But if I convert them to z-scores and use negative 2.5 and negative 0.5, then I totally know how do you find the area between two z-scores. Normal CDF, right? So we need to first take our x values, change them into z-scores, so then we can just use normal CDF on them. We totally know how to find the area between two z-scores, or the probability between two z-scores, right? Area is probability. Find the area between two z-scores. Good. So what did you say again? Can we put it all together into like one clean thing? You said 30.23%, is that what you said? What? Of the population, sure. Population of what? Yeah. Chocolate bars. Chocolate bars. What? Sure. Lies between 200 and 220 calories. That totally works. Yep. Yeah. Okay, good. All right, so you guys need just another minute to finish up D, and I want you guys to take a minute. Do D. You already calculated the z-scores for it, so you don't need to calculate that again. But you do need to draw a picture and say what it means in words. Okay, so let's take a look. So you guys drew a picture. So you have your little hill, and then your line across and notch in the middle. And then x is 200. Which z-score is that?
Negative 2.5.
Negative 2.5. So you're going to put negative 2.5 in on the left or the right? The left. I don't really care where, just on the left somewhere. All right, line above, and I want, do I want less than or more than 200? Less than. So it's going to be the left or the right, guys?
Left.
Left. Which means my other z-score is going to be way out here, negative infinity. Okay, what's next? How do I solve the rest of this?
Normal CDF.
Yep, normal CDF of negative something large, 72, comma, negative 2.5. What did you guys get?
0.0062.
0062. This is any large number. Okay. Okay, 0.0062. What does that mean in words? Somebody else. Somebody over here. Anjali, go ahead.
0.62% of all chocolate bars are under 200 calories.
Yep. Chocolate bars are under 200 calories. Great. Good. The other one that you guys didn't touch on, you could have said also, is a randomly selected chocolate bar has a 0.62% chance of being under 200 calories. Those kind of basically, those two ways of looking at the same thing. All right. Other thing we talked about last class was about how sometimes we want to find a z-score where a certain percentage of the population lies above or below this. So here we're given an area or percentage, and we want to find z. So for example, I am some horrible peach farming tyrant, and I have all these peaches, and I want the bottom 15% of peaches weights, I'm going to force all my small children I have working for me to discard them and put them into a bin to be canned. But I can't just say, hey, you small children, you know, I have to tell them what ones should be in that section. You know what I'm saying? So I need to figure out what the bottom 20% of all weights of peaches is. So here, it's going to be a little bit different. We'll use inverse norm with our TI calculator to find this z-score for an area on the left side of a normal curve. So we talked about this a little bit last class. Remember, here's my normal curve. Inverse norm of 0.25, that's the left area. This is the left area. Left area. By left area, I don't mean the area you left. I mean the area on the left. So it means that this is this area over here, 0.025. It's the area on the left side. Left side of what? Left side of this z-score. So here's a z-score. It has an area on the left of it, it has the area to the right of it. The area to the left of it is this. Inverse norm of 0.023 gives a z-score of negative 1.96, which means that the z-score of negative 1.96 has an area on the left of 0.025. These are inverses. Remember we talked about that last class, how I said if we took this little section here, and this z-score out here would be negative infinity, then we'd say that normal CDF from negative infinity to 1.96 is equal to 0.025. And because of that, the inverse norm of that answer, 0.025, had darn well better give me 1.96, or there's something wrong. Right, so this number has to be there. In other words, whatever this number is here, normal CDF from negative infinity to this number, the answer I get here, if I do inverse norm of that answer, I should get whatever I put in here. And that's what we did. We did that last class. All right. So let's move on. Here's your quiz problem 3. Find the z-score where this percent of the population is less than it. So this is 0.0158 is on the less than side. Is that the left or the right?
Left.
Left. 0.0158 on the left. We need to find out what this z-score is, so we're going to do inverse norm of the area on the left. What's the area to the left of this z-score? Not a trick question. What's the area to the left of this z-score? Yeah, just right here. It's this area. It is this area here. Right. Here's my z-score. The area on the left is that area. I don't care about the area on the right, but that's my left area. I only need the left area. If I have the left area, I'm all good. So what is that area? Not a trick question. What's the area?
0.0158.
Yes, 0.0158. Great. What did you guys get?
Negative 2.15.
Negative 2.15. Great. Now, we have the other one, which is 25% of the population is greater than or equal to it. So here's my area. Where's the 25%? Is it on the bigger side or the smaller side? Bigger side. So is that going to be the right or the left?
Right.
The right. It's greater than. It's over here. 25% is over here. here's the deal. I want this z-score, but in order to use inverse norm, I need to feed inverse norm the area to the left of it. So you need to find the area to the left of it and then feed that into inverse norm. All right, take 30 seconds, find this. If you haven't already.
Oh, because it's good.
Okay, so what's the area on the left side?
Oh, A. That's B.
0.75, 75%, because if 25% is on the right, 75% has to be on the left. So you guys are going to do inverse norm of
This was also
0.75, and what are you going to get? 0.67?
4, 5.
Great. Yeah, if you round, just round to two decimal places. Remember, z-scores, 2 decimal places. Areas would be 4, you could go out to 4 decimal places. Especially on the homework. If you don't do 2 decimal places on the homework for your z-scores, and 4 here, then you're going to get errors all over the place. It's going to kick out, it's going to kick back your answers all the time. Because it assumes you're using a z table, and we're not using z tables. Now, here's this part about the peaches. I have a z value. I found my z value, whatever it was. What was the one we found last? At the bottom. I found my z-score, and I can't just say to my slave small children that I've enslaved, I can't just say, all peaches with a z-score of negative 1.4 or less you should put into this pile. They're not going to know what I'm talking about. They're going to say, oh, that crazy evil lady, she's making no sense again, right? What you have to do is I have to say, I have to convert that z-score into an x value. And once I do that, then I can say, oh, all peaches that are less than 4.6 ounces, then you put those, kick those into the canning file or whatever it is, right? Not into the selling file section. So we need to convert every z-score into an x value at the end, usually, right? Because you want to know what it is for your peaches, or whatever it is. So what do? How do you figure out what is the z-score again? What was it? What's the idea of a z-score?
The number of standard deviations of values above or below the mean.
Yeah, the number of standard deviations of value is away from the mean. An x value, the number of standard deviations in x value is away from the mean. So, how do I figure out it is? I start with my mean, and it should be that many standard deviations, this many standard deviations away from it, right? So all I'll do is take my mean and add that many standard deviations to it, and that I should be able to get to my x value. If it's negative, then I would subtract that many standard deviations. So that's what it is. You take your mean, and you add that many standard deviations. So that's how you figure out what the x value is. All right. So here are the basic ones. So again, here are the steps. You just draw a picture. Find the left area, meaning the area on the left of the value you want, of the z-score that you want. And then use inverse norm of that area on the left to figure out what the z-score is that goes there. So this is the middle of page 6. You guys probably have it filled in already. And then you use normal CDF of that area to find the z-score, and then you convert the z-score to an x value. Okay, all you guys have that already. Here it is pictorially. Pictorially. My first step is going to, which I may or may not need, is to find the area on the left. So first figure out what your area on the left is. The second step is use inverse norm of the left area on the left, to find the z-score. And the last step is to, sorry, that's the second step. And then the third step is to convert that z-score to an x value. This may be more confusing than I pictured in my head. I don't know. All right. So you guys do lab problem 5. If you need a reminder of what lab problem, what we did last class, this is the this is the, oops. Oh. This is what we got. This is the example we did last class. So this is the example from page, right below that. So right here, the Police Academy one. And then you're doing the one on the very next page, lab problem 5 on the next page.